Here we go on question number 4. Do students sleep the amount that conventional wisdom says they should, which is 8 hours a night? We are asked here whether we have significant evidence from the data given to determine if students are sleeping less than conventional wisdom says they should. That is 8 hours a night, not 2 or 3. So I know because it says significant evidence that I must be performing a hypothesis test, and the next question is whether or not, or what type of test I'm using. If I look at Grandma's recipes, there's several types of hypothesis tests. If I look at the data, I'm told the mean number of hours per night, which is a quantitative variable, so I'm dealing with mean, so it's one of these two. And then I need to know, is sigma, the population standard deviation, known or not? And if I look at the standard deviation given, it says that the standard deviation is 0.82, and that refers to the 20 students. So that is a sample standard deviation. In other words, the population standard deviation is not given, and I'm using this formula right here with the t. So for my hypothesis step 1, I will state the hypotheses. I will begin with the alternative, and the alternative is that we are asked to test if students are sleeping less than conventional wisdom says they should, which is the mean less than the 8 from conventional wisdom. And if I look here, the less than immediately tells me I'm dealing with a one-sided test. Then the null hypothesis would just be that the mean is equal to 8, and from that I can go ahead and move on to calculating t. So the formula for t is going to be that t is x bar minus mu all over s over root n, and I will also need to find the degrees of freedom for that. So I like to write down what all I need to know in order to plug in here. I need to have x bar, s, and n. The mu is the population mean that I'm testing against from the null hypothesis, which is 8. So reading the question, the sample mean is 7.5, the standard deviation is 0.82, and the sample size is 20. From that sample size, I can calculate the difficult calculation that the degrees of freedom is 20 minus 1, or 19. If I go ahead and plug in these numbers, I have 7.5 minus 8 all over 0.82 divided by square root of 20. You may want to pause and calculate this right now. When I calculated it, I got a negative 2.72 for t. So in step 3, I go to actually finding my p-value. And for that, I will need to go to the table, look up in the t-values for degrees of freedom 19, look for a 2.72. If I look at my table, degrees of freedom's 19 right here, and I will look for the 2.72, which is over in between these two numbers. So then I come to the bottom. This is a one-sided p, so I'm looking right here between 0.01 and 0.005. And I can just go ahead and average those two. It'll be a 0.01 plus 0.005 divided by 2. When I average them, I get a 0.0075. So my p-value is roughly 0.0075%. Last step is to make a conclusion. Since the significance level is not given, I default to a significance level of 5% or 0.05. 0.0075 is smaller than 0.05, leading me to say that this is extremely unlikely to have this data, and thus I can conclude that I have significant evidence that students sleep fewer than 8 hours per night. And that's all there is to it.